Morning, students. Today we'll be looking at a new topic called data analysis and visualization. So this is the first topic from this. So we'll be covering this today. So what we'll be doing today is to talk about understanding the scope of data science and the roles of data scientists. This is the unit aim. So the unit is essential for understanding the fundamentals of the data analysis process, including gathering, cleaning, analysis, and sharing data and communicating insights with the use of visualizations and dashboard tools. It is expected that students doing this unit will gain hands-on experience of implementing data analytic process and techniques using a programming language such as Python, R, or a tool such as Weka, KNIME, Power BI, Excel, etc. This is the content, indicative content. So the first one, population sampling categorical data, nominal data, ordinal data, continuous data, discrete data. Regression analysis, Monte Carlo simulation, factor analysis, cohort analysis, cluster analysis, time series analysis, sentiment analysis. The second one, which is descriptive data analytics, predictive data analytics, and prescriptive data analytics. The next one is variable identification on univariate and bivariate analysis, missing values treatment, etc. through graphs, charts, plots. As usual, we have another video to watch, but we'll definitely be watching this after the session. So, definition of data analysis. Data analysis is the process of inspecting, cleansing, transforming, and modeling data to discover meaningful patterns, draw conclusions, and support decision-making. What other thing can we say about the definition of data analysis? We can only say that data analysis allows us to extract insight and value from raw data. Who is a data analyst? A data analyst retrieves and gathers data, cleans and organizes it, and studies it to conclude meaningful insights for the organization with the help of analytics skills. So these are the key aspects of our talk today. We'll be looking from the range of, we'll be looking at data collection, data cleaning, among other things. Also, we'll be looking at data transformation. What is data collection? We should have an idea what collection means. Collection literally means gathering from various places or sources. So we can as well say that gathering relevant data from various sources. What is data cleaning? Removing errors, inconsistencies, and outliers from the data. The next one, data transformation. Restructuring and organizing data for analysis. Exploratory data analysis. This is conducting initial analysis and visualization to understand the data's characteristics. What is statistical analysis? Applying statistical techniques to uncover relationships, correlations, and trends. So the next one is looking at the importance of data analysis, of data analysis. We have to understand why we're analyzing our data to better understand what we are trying to do with the data. So the first one is business, driving strategic decision-making, optimizing process and identifying market trends. Science and research, validating hypotheses, identifying patterns and drawing scientific conclusions. Healthcare, analyzing patient data, detecting diseases and improving treatment outcomes. How data analysts help organization is the next topic. The next subtopic. So these are the ways in which the data analysts help organization. The first one is encourage disciplined thinking, create advanced statistical modeling technologies, predict and improve business performance, bring technical expertise, provide quality assurance data. We also need to know the skills required for a data analyst. You must have an idea on SQL, Python and or R, Alteryx data tool and Tableau, big data, relational database, knowledge of neural network, deep learning, or AI. We can see in this image, we have data analyst skills. So these skills range from the first one, which is organizational skills, to data visualization tools. It's literally almost the same thing as what we spoke about here, but this is the visual diagram of it. So you must have an idea of you must have an organizational skills. You must be able to solve problem analytically. You must know data concepts, have an idea of R programming, artificial intelligence, statistical analysis, Python, and data visualization tools, e.g. Tableau or Power BI. These are the tools to know. These tools start from R to PySpark, Power BI, Pandas, Tableau, Python. So these are the tools required for a data analyst to know. So you might be asking yourself, how do you become a data analyst? The first one is by making a learning plan, build your own technical skills, work on projects, develop a portfolio, practice presenting your work. What is data extraction? This is the process of extracting or retrieving data sources for further data processing or data storage. Python libraries for data extraction. We have PyPDF, Scrappy, Request, Beautiful Soul Up. So obviously, to have more idea about this Python library, you can come here. You can visit this link to have more idea of it. So in our slide, we have beautiful soup. Beautiful soup. So you can read through this. You can read the features, pros, and the cons. That means the advantage and disadvantage of it, and so on. Scrappy also. So this is the link that you can use to read through it. Also, we have request, which is literally in our slides. So what is data visualization? Data visualization refers to the visual representation of data and information using charts, graphs, maps, and other visual elements. Its purpose is to communicate complex data in a clear and concise manner, allowing viewers to easily understand patterns, trends, and insights that may be difficult to design from raw data alone. What are the types of data visualization? We have charts, we have maps, we have infographics, we have dashboards, we have data visualization tools such as Tableau. The first one, chart and graphs. Bar charts, line charts, scatter plots, pie charts, and histograms are commonly used to represent numerical data. Maps. Geographic data can be visualized through maps to show spatial patterns such as population density, distribution of disease, or election results. The next one, infographics. This visual representation combines data, text, and design elements to convey complex information in a visually appealing and easily understandable format. Dashboards, interactive display that consolidates multiple visualizations, allowing users to explore and analyze data in real time. Dashboards often provide a holistic view of key metrics and performance indicators. Data visualization tools and software such as Tableau, Power BI, and Python libraries like Matplotlib and Seaborn facilitate the creation of visualization. These tools offer a wide range of customizable options, enabling users to tailor visualizations to their specific needs and preferences. Effective data visualization involves thoughtful design choices, such as selecting appropriate chart types, using data effectively, and providing clear labels and titles. The goal is to present data accurately and understandably, fostering data-driven decision-making and enhancing data literacy. So our next topic is assesses data analysis activities, techniques, and tools. Activities, techniques, tools. So the first one is to look at what activity is it. So this involves data cleaning, exploratory data analysis, statistical analysis, predictive modeling. So what is data cleaning and pre-processing? Pre-processing. This involves handling missing data, removing outliers, transforming data formats, and ensuring data quality before analysis. Exploratory data analysis, EDA. EDA involves examining and visualizing data to identify patterns, trends, and relationships and gain initial insights. Statistical analysis techniques such as hypothesis testing, regression analysis, and clustering are used to analyze data, test hypotheses, and identify associations. Predictive modeling. This involves building models using machine learning algorithms to predict future outcomes or make informed decisions based on historical data. Right here, we can see a flow of activities from text mining and natural language processing, NLP, to time series analysis, data visualization. The first one, text mining and natural language processing. These techniques analyze unstructured text data to extract meaningful information, sentiment analysis, topic modeling, and text classification. Time series analysis. This technique is used to analyze data with a temporal component such as stock prices, weather patterns, or customer behavior over time. Data visualization. Visual representations such as charts, graphs, and dashboards are created to communicate findings, patterns, and insights effectively. We'll be looking at techniques now. We've already looked at activities because we know that we're meant to look at activities, technique, and tools. The next one is technique. Descriptive analytics. Techniques used to summarize and describe data, including measures of central tendency, variability, and distribution. Inferential analytics. Statistical techniques that make inferences about a population based on sample data, including hypothesis testing and confidence intervals. Machine learning. Algorithms and techniques that enables computers to learn patterns from data, make prediction, and automate decision-making processes. Cluster analysis. Techniques to group similar data points together based on their characteristics or similarity measures. Regression analysis. Techniques to model and analyze. So, as we said before, we'll be looking at the tools. We have programming languages. The popular ones are Python, R, and SQL. Provide extensive libraries and frameworks for data analysis, statistics, and machine learning. Data visualization tools like Tableau, Power BI, and Matplotlib in Python enable the creation of interactive visualization and dashboards. Statistical packages, software such as SPSS, SAS, and Stata provide comprehensive statistical analysis capabilities. Data mining tools like RapidMiner, KNIME, and Weka offer a range of data mining techniques and workflows. Machine learning platforms such as Scikit-learn, TensorFlow, PyTorch provide powerful tools for building and deploying machine learning models. Data cleaning and preparation tools. Tools like OpenRefine, Trifactor, and Alteryx help automate data cleaning, transformation, and preparation tasks. The next thing we'll be looking at is evaluate the three types of data analytic methods and their use in industry. We have descriptive analytics, predictive analytics, and prescriptive analytics. The first one, which is descriptive analytics. What is descriptive analysis? This involves the analysis and interpretation of historical data to gain insights and understand patterns and trends. It focuses on summarizing and presenting the data in a meaningful way to describe what has happened in the past. Sales analysis. Retail companies use descriptive analytics to analyze sales data, identify top-selling products, track sales performance over time, and understand customer buying patterns. Financial reporting. Finance departments utilize descriptive analytics to analyze financial data, create reports or revenue, expenses, and profitability, and generate visual dashboards for management and stakeholders. The last one, which is not really clear, is customer segmentation. Marketing teams use descriptive analytics to segment customers based on demographic, behavioral, or purchasing patterns to tailor marketing strategies and campaigns. So the next one is predictive analytics. So what is predictive analytics? This one focuses on utilizing historical data and statistical modeling techniques to make predictions or forecasts about future outcomes or behaviors. It involves identifying patterns and relationships in the data to develop predictive models. Predictive analytics techniques include regression analysis, time series analysis, machine learning algorithms, and data mining. This method finds extensive applications in industries such as demand forecasting. Retailers use predictive analytics to forecast product demand, optimize inventory levels, and plan production and supply chain activities. Fraud detection. Financial institutions employ predictive analytics to detect fraudulent transactions by analyzing patterns and anomalies in customer behavior and transaction. We obviously can know that most top banks like Barclays, Santander use this kind of fraud detection to know and to detect fraudulent transactions. So they analyze the patterns and anomalies in customer behavior and transaction data. Churn prediction. Telecommunication and subscription-based industry use predictive analytics to identify customers at risk of churning and implement targeted retention strategies. The last one, which is prescriptive analytics. Prescriptive analytics goes beyond descriptive and predictive analytics by suggesting the behavior course of action to optimize outcomes or achieve desired objectives. It leverages optimization techniques, simulation modeling, and decision analysis to provide recommendation or decision support. Prescriptive analytics is particularly useful in industries facing complex decision-making scenarios. Examples include 1. Oh, I think don't have the example of this. Give me a second to check it. So we can see here that we have example of prescriptive analytics in action. We have venture capital, sales, content creation, banking, product management, marketing, among others. So you can either Google it or use this link to know more about prescriptive analysis. The next subtopic we'll be looking at is demonstrates an ability to use a popular programming language or tool used in data analytics industry to solve a problem. Number one, problem, analyzing and visualizing sales data. Suppose you have a data set containing sales data for a retail company and you want to analyze and visualize the sales trends over time. Solution, to solve the above problem, we can use Python along with popular data analysis and visualization libraries such as Pandas and Matplotlib. Here's an example code snippet that demonstrates how to load data, perform analysis, and create a line plot to visualize sales trends. So this is one. We have Jupyter Notebook code. Obviously, we have to import the library and load the data using our data is obviously CSV. So we have to load the data from a CSV, perform data analysis. So we can obviously go by month sales and get the sum of the monthly sales and then do a line plot to visualize sales trends with this code. So let me kind of find a way to split this into two so that we can have the code and the explanation in one. So that's 28. So we have this. And let's do like this. Okay. Do like this. Give us a second. Yeah, I think it's okay like this. So in this code that we're looking at, we first import the necessary libraries, pandas and matplotlib. We then load the sales data from a CSV file using the read CSV function from pandas. The next thing that we did was to perform data analysis by grouping the sales data by month and calculating the sum of sales for each month using the group by function. Finally, we create a line plot using matplotlib to visualize the monthly sales trends. The plot function is used to plot the data points, and additional functions are used to set labels, titles, and customize the plot appearance. The show function displays the plot. By running this Python code with your sales data, you will obtain a line plot showing the monthly sales trend, helping you understand the patterns and identify any notable changes or seasonality in sales over time. So Python versatility and availability of various libraries make it a powerful tool for data analysis and visualization in data analytics industry. It offers numerous capabilities for data manipulation, statistical analysis, machine learning, and more, making it preferred choice for many data professionals. This brings to the end of our topic today on data analysis and visualization. As usual, for your personal study, these are the references used for these slides. And also, don't forget to refer to the books and journals on the module for this unit, and email us if you have any question, and email the email above for assignment. Thank you very much for coming in today. But before we go, let's watch this video.
Data analytics is the buzzword you would have heard. What is data analytics? Data analytics is the buzzword you would have heard a lot about in the recent years. To put it simply, it's the process of analyzing raw data to get insights and find patterns about the information. Using various techniques and processes, the raw data is transformed into a format which could be further visualized and be made human readable. To understand the definition in an even clear way, let's take a look at this example. John, who is a digital marketing professional, is running an online advertising campaign to promote a new smart television. John starts by targeting the group of people who might have bought the previous versions of the smart TV in question. As said, campaign runs, data analytics comes into the picture through the data generated whenever people clicked on the published advertisement. Now, by inspecting the data about these users' interest and their buying patterns, you might come across that many of them are interested in streaming 4K UHD video. The reason behind this might be that the new smart TV has a better streaming quality than the previous versions. Using this information, you could tune in your advertisements to focus on users who bought the previous version of the smart TV and are interested in getting 4K streaming quality. This data can also be used to attract new customers who did not go for the previous version of the smart TV but are very interested in a better version of the TV. Why is data analytics significant? Businesses use data analytics to optimize and grow by making better business decisions and finding more efficient ways of doing business. The company can build new and better products with the buying patterns and better understanding what the customers need. So how do data analytics work? The data analytics process has some components that can help a variety of initiatives. By combining these components, a successful data analytics initiate will provide a clear picture of where you are, you have been, and where you should go. Generally, this process begins with the descriptive analysis. This is the process of describing historical trends in data. Descriptive analytics aims to answer the question, what happened? This often involves measuring traditional indicators such as return on investment. The indicators used will be different for each industry. Descriptive analytics does not make predictions or directly inform decisions. It focuses on summarizing data in a meaningful and descriptive way. The next essential part of data analytics is advanced analytics. This part of data science takes advantage of advanced tools to extract data, make predictions, and discover trends. These tools include classical statistics as well as machine learning. Machine learning techs such as neural networks, natural language processing, sentiment analysis, and more enable advanced analytics. This information provides new insight from data. Advanced analytics addresses what if the question. Data analytics affects every aspect of our day-to-day lives. You may not even realize it, but you probably use data analytics almost every day. Here are some of the everyday applications of data analytics. Social media stats instantly register anytime there's a visitor or a post to a page. Cell phone bills can pull up months of calling data to show you patterns of usage. Sensors monitor the changing weather and report the data to you instantly on your smartphone. Sports fans collect statistics on their favorite athletes and often use the data to form the term of fantasy leagues. Schools across the nation are involved in high-stakes testing that generates voluminous data on each student's progress. Educators then utilize data generated from extensive reports to drive their instruction. Data analytics is a growing field and will always be a top domain to get into. The average salary of a data analyst in India is 7 LPA and in the US it's $70,000. There are 27,000 plus data analytics jobs available only on LinkedIn, and there are very few skilled professionals to fill that gap. That's all about data analytics.
So this brings to the end and conclusion of our topic today. So just for recap, we started the new topic on data analysis and visualization. The first thing that we looked at is to understand the scope of data science and the rules on data scientists. We looked at the unit aim, the content, among other things. We looked at descriptive analytics, among things, and the activities, the tools, prescriptive analytics, and all. So thank you for coming today, and hope to see you next time.